Yeah, today we will see the continuation where we left on the last video. So yesterday we have completed modeling for the suction lines. Okay, so in that somebody asked why we didn't model this flange. So we need to, we will model. If you want to model, you can model. So if you want to include the weight of the flange, you can include the weight here. So for that, we need to check what is the type of flange they use. So yes, I think we have seen yesterday, I mean, it is a slip-on flange only because the length of the flange is very less. So, and also you see, it's like a slip-on only. So we will take the weight from pipe data pro, 4-inch slip-on, 300 rating. The dimension is 4 to 6. So what you can do, you can break this one, 10,005, and it is 4 to 6. You enter the weight, 10 plus 3, 13. So you can give 13.16, that is 13 means 130, 132, we meant it as 132. And here also you have to do the same thing, Control B. So don't go by CAESAR default node number, so you have to change according to our requirement. 105, 46, and the database is 138 too. Okay, so you can do like this also. So now we have completed suction line. So we have not defined the temperature here. One is working and standby as per P&ID. One is working and standby, it is given clearly. Okay. As you see, one duty, this is a pump. Two numbers, one duty, one working and one standby. So what we will do, we will do the modeling. We will distribute the temperature accordingly. So now so far we have given 3 temperatures, that is T1 as maximum design temperature and T2 as this is maximum operating temperature and T3 as minimum design temperature. See, in all cases the support saddle, that is the leg of the vertical vessel, is ambient temperature. We have to use the ambient temperature since there is no fluid flow in that particular location. So we have maintained the temperature. Okay. For pumps also you can do like this, but it's a very small portion, so we have maintained like this. Okay, it's a negligible, so we can do like this. It will not have any impact. Oh, so after doing analysis, if you come to know if your nozzle is marginally exceeding the allowable, then we can do like this. But if you if you change the temperature, means because of the temperature difference, the expansion also will vary. So we will get different results only. I will show you while checking the results. Okay. And T3 now. So what we are going to add is, so if you go to the model, this is a 3D model. So this is the valve. So the fluid is coming from here to here, and it is going to pump suction. Okay. So if one is working, for example, this line is working, means this valve has to be closed. All right, now this valve has to be closed. So what does it mean? There will not be any fluid flow up to here, and here also in the discharge line also we don't have any fluid flow. So up to this valve also will be closed, because this pump only will be in operating condition. This pump only will be in operating, and this is, if this is in standby condition, means, so from this valve to this flange, and for the discharge line from here to this one you have to make the temperature as ambient. Since there is no fluid flow, you have to make the temperature as ambient. Okay, so first we'll see, you can select any one pump, that is not an issue. For example, this is A pump and this is B. I am taking first, you don't touch the three temperatures whatever we have defined, no? So don't touch the three temperatures. Go to the fourth temperature, fifth temperature. If two pumps are there means there will be only two combination. One is if this is working means this will be standby, okay, or this is standby means this will be working. Only these two combination only will come. Okay, so we need to add two more temperatures, T4 and T5. Okay, so for example, if you have three pumps, so what happened? Two working and standby, working, standby. Okay, then working, standby, working. Okay, then standby, working. So there will be three combinations of temperature we need to use. So in those cases, what we need to add temperature T4, T5, T6. Three temperatures we need to add. So depends on number of equipments. So the temperature distribution also will vary. If working and standby condition, if you want to maintain, or if two pumps are working, it is good, no need to add any more temperatures. So whatever we have done that is correct, then we'll go with the analysis. Okay. So now we will see how to define the temperature. So how we have modeled here. Yesterday, we have model like this. Okay, so up to here we model. Okay, after that we copied this and we have done the modeling. So what we'll do, we will consider this fourth temperature from here onwards. Enter, first you need to enter 4 and 5 temperatures. For that, what you have to do, go to elements. So you just define the temperature here. For operating and standby, means working and standby conditions, always you have to use operating temperature. Means for this line, operating temperature is 40 degree. So I have to enter for T4 as 40 degree and T5 also 40 degree. So you have to define like this, means if you enter the temperature at first node, automatically it will get updated here. Okay. Okay, so now if you select now here, you see two more temperatures has been added. So T4 means all cases it is T4. So I mean 40 degree. So we will change this saddle, the equipment later, we'll see. Okay. So now from here onwards, because your fluid will be like this, your fluid flow is like this. So up to here fluid will be there. So it will be in operating temperature. Okay, and here also operating temperature, because this is working. Now this is standby. We are going to consider like this. Okay, so from here onwards, what will happen? From here to this pump, it will be ambient temperature, that is 21 degree. So we need to define here T4 as ambient temperature here from this node. Okay, you have to select the node properly. So now if you select here T4, you see from here onwards it's red, it's in red color. That means your ambient temperature you have defined up to this pump. So why this line also got changed, means we have copied this one. Okay, so if you go to next node, what happened? So it is continuing from this node. So what we need to change? So at this node, select this node, change this as 40 degree. That is working. So this pump is working, means so you have to select as 40 degree. You have to change. Okay. So now you see what happened. So this pump is not working. So we have maintained 21 degree as ambient temperature. You see, but on the pump it is not changed. So again, what we need to select this one and change it to 21 degree. Because since this is in standby case. So you see, then your temperature also changed for this pump. So for this again you need to change it to 40. Understood, no? So like this you have to change. Okay, so we'll see. And for the saddle, what we need to do for this support, you can change it. The lowest node you can change. You see, the first 3 temperature is 21 degree. This is for the saddle equipment support, and you make it as 21 degree. So now you see T4 is, this is 21 degree, and so this is standby. Now if you select T5, so all our operating, it will consider like all our operating. Now we are going to consider this as standby and this pump as working. Okay. For that, what we need to do from here to here, it should be 21 degree. Okay. So you have to select this node number and change T5. T4 already we have changed that side, that pump. So now you have to change this one as T21 degree. So now you see, this is completely standby and this is working. But in the pump you see, because what happened means we have continued model here. So you have a model like this, and the next node, what will happen? It will take the value from this node only, previous node. That means previous node is 2850. From 2850, it will be continued to the next node. So if you want to change it, you can change it here, or you can see in elements. In the elements, you see, up to 2850, it is 40. That is T4. Okay, you see here, it is 21 degree. So what happened from this node? If you want to change it, you can change it here also. This is what we have selected, is this pump. So we need to change this one as 40 degree. So now you see it has been changed. But if you update here as 40 degree, so it will be continuing for the next nodes also. So you should be very careful. So next, so here it is operating. So it should be standby only. So again, what we need to change? We need to change it to T5 as 21 degree. So now from here to here it is standby. From this valve to till the pump, it is standby, all over 21 degree. But if you check here, this one has been changed. So you have to be very careful. That's what you need to check all the parameters. After completing the model, you need to check thoroughly. So 10130, go to the next node, you change this as 40 degree. Okay, so now you say temperature has been changed. Now it is correct. Okay, so now we have completed the modeling for this one, for the pumps suction line. So we'll see how to model the discharge line. So you can model here also. You can continue with the model discharge line in this file itself, or you can continue the model in the other file. You save this one and make it as other file, and you can import that file to this file. So anything you can do. Okay, If you know the coordinates, you can model from this file. We will see discharge line. So this is the discharge line. So since I don't have the isometric of this particular discharge line, so what I have done, I took the same. This is train A, and adjacent to this train B will be there. Yeah. So I took the ISOs for this discharge line. Okay, we will model. Okay, so what we will do, we'll copy this file, open, and copy this pump suction. Copy, or if see, copy and wait for some time, paste it here. Then you can change this. You can change the name as discharge. So if you open that file, okay, so the same, pump suction is separate file and this is separate file. So what we will do, okay, in that pump suction line, we have defined the uniform loads. Okay, already we have defined in two directions only, 0.141 G in X direction and 0.141 G in Z direction. Okay, so based but here we have not used wind because the line is under 10 meter, so we have not used wind, and the line size also lesser than 12 inch. That's why we have not used the wind loads here. If you want to use the wind loads here, you have to double click this wind wave and provide the wind shape factor. Okay, wind 0.7 or 0.6 based on your design basis, based on the site condition. So now what we are going to do, we need to remove all the things. We'll keep the first node only. So you select from here to here, right click, block operation, delete, or it just in the delete, if you give means it will get deleted. Okay, now we will see the discharge line isometric drawing. So this is one of the discharge line isometric drawings. So this is a starting point, discharge line, nozzle lane 2. So yesterday we have seen N1 is for suction and N2 is for discharge. What we will do, we will start modeling. First we need to enter the design parameters and line size. So here you see it is starting from here. If you go to 3D model, so it is going like this, and this here it is like that. Okay, so here we need to model trunnion. We'll see how to model the trunnion support, but we'll do it later. Okay. What happens first, we need to see the size, that is F10, flange 10. Go to part number 10. The line size is 3 inch, schedule 40S, and A182 F316L, that is A312 TPC16L. Line size is 3 inch. So we have to change the line size is 3 inch, 40S. Okay. And then corrosion allowance will be 0 only since it is stainless steel. You need to change the line number. What is the line number here? 7047. I have to change this one to 7047. Okay. And you have to pipe density remains same only because stainless it is stainless steel, and fluid density you have to take it from line list. Go to line list. This is our 40. So our line is 47, and what is our density? 1105. Okay, so you can use the same density 1105. And what is the temperature? Okay, so now when the fluid density is 1105 as per the temperature, as per the line list. Next is temperature. You see, design temperature is 65. So yesterday I told if the design temperature is below the solar radiation temperature, then we have to use the solar radiation temperature. So this is a piping design specification, stress specification. See, this is a point. See, it is given any uninsulated pipe with design temperature below 82 degree and is subjected to solar radiation heat gain shall use minimum of 82 degree. So this one we need to use for this particular lines, for this particular system. Okay, so that's why we are using 82 degree. If it is an insulated line, but it is not subjected to solar radiation, means it will be in inside any building, so no need to consider solar temperature. Okay, since this line is outside, it is not inside the building, and it doesn't have the insulation, so it is uninsulated pipe. So for this reason we need to use 82 degree here. So we need to enter 82 degree, and what will be our operating temperature? So maximum operating is 40 degree. So we are using the same only here. And minimum design they have not provided. That's why we have used 4 degree yesterday. Okay. And then design pressure, it is 6.5. Sorry, 6.1. So its unit is bar only. So 6.1. And test pressure, what is test pressure here? It is 9.5. That is test pressure test. It is 9.15. So enter is 9.15. And material is A312 TP316. Code is 31.3 only. So save this. And then go to the isometric drawing. So this is the isometric drawing. So this is 3-inch 150 rating flange. So here it is well neck flange, 3-inch 150, scheduled 40 years. The dimension is flange thickness is 70 mm. Okay. Then weight is 4.97. 4.97 plus 0.79. Okay, into how much? 5.76. So you can give 558. You can consider 58. What is the direction? It is going up, so it is in vertical direction. Okay. So here. So it is in vertical direction plus y, and the dimension you have to delete this one. This was from the previous one we used. 70 mm upwards. Okay. And what is the weight? 58, 57.6, 58 we'll consider. Okay. And it is moving upwards. And what is the dimension? 142 is there, you see. 142. So this 142 you have to subtract the flange length. Go to the next node. So minus 70 plus 142. And then one reducer is a 140 reducer, 3 by 6. So 140. I have to enter reducer here. This is a concentric reducer. And item number is 4. So go to 4, part number, concentric reducer, 6 by 3. 6 by 3 and schedule 40s. 6-inch schedule 40s. So you have to enter the second diameter, D diameter is 6 inch and schedule 40s. Go to the next node. If you go to the next node, automatically your line size will be changed. And what is the dimension? 446. Okay. 446 on bend is there. And then it is going in which direction from here? So it is going in plus Z direction. Okay. So what is the dimension? 574. Go to the next node. I'll go a little bit first. Okay, it's 574. Then elbow is the double click the bend. Go to the next node. Then 317 including the flange. So yesterday the flange dimension of 6 inches 89. So I have to subtract 317 minus 89, 228. But 6 inch of elbow length is 229. So you enter 229, not upwards, sorry, I entered wrongly. It's going in downward direction. Okay, correct, no, it is going in downward direction. So it should be minus Y. Go to the next node. And the dimension is 89 as we have already seen. So you have to take the flange length and weight from pipette approved, including stud bolt. And then next is 154 on branch is there, that is 3 by 4 inch. If you want to neglect it, you can neglect. So 154 plus 89. So it will be a socket. So I am going to use socket here. Then go to the next node. What is the dimension? 294 minus 294. So here one bend is there. Okay. So you have to select bend here. And after that, how the line is traveling? So it is traveling in minus X direction. Correct, no? This is plus X and this is minus X. So your line is traveling in minus X direction. So you see what is the dimension here? 229. Only the elbow length they were provided. Go to the next node. Minus 229. Okay. Then go to the next sheet. First, if they provide the isometric drawing, so you have to rearrange the sheet. You have to arrange the sheet in such a way that how we are going to model. So before proceeding the model, you need to check the 3D model, or if you have 2D drawings, you check the layout. Based on that, you arrange the sheets. So then only it will be easy for you. Okay. Go to the next node. So it is coming from sheet 1. It is going to sheet 2. You see, sorry, for continuation, sheet 3. It is going to sheet 3. What is this sheet? This is sheet 3 only. Sheet 3 of 6. You see, the line, it is coming from here. Okay. So from here to here, 225 dimension is there. Go to the next node. Minus 225. And on branch connection is there. You enter socket here. 3/4 inch, no? Okay. Then 188 is 188 including the flange. You have to subtract the flange length. That is minus 89, not minus 188 plus 89. Okay, then only your value will be correct. Go to the next node, minus 89. So I forgot to tell you one thing. We didn't provide the coordinates here. So we need to. So we'll see after completing the modeling. Also, we can provide the coordinates. Once we complete the model, we'll provide the coordinate. And this is 104. So what is 16? It is NRV. 16, they have not given anything. So that is NRV only. Okay. Check valve. So 16 is check valve. Valve, flange valve, 6 inch, 150 rating check valve. Sorry, this is not check valve. So we need to check whether it is a wafer type check valve or swing type check valve. So select 6 inch and 150 rating, raised face, not RTJ, raised face. So if you see the dimension, you can identify. Wafer check valve will have the lesser dimension, and swing check valve will have more dimension. 6 inch means, see, 356. Okay. So wafer means you will have small one. The dimension is 98. So it's approximately matching with our dimension. Here you see 104. So we will use wafer check valve dimension. Weight 180, 18 kg. So I'm multiplying by 10. Go to the next node, minus 104 and 180. Again, go to the, you see some branch connection is there. If you want to model, you can model, or you can go straight also. Not only, just I'll show. 162 plus 219, 381. So both side flange we need to deduct minus 89, minus 89, 203. So dimension will be 203, minus 203. Then one flange is minus 89, 138, and one spectacle blind also there. Say this is a spectacle blind, and the dimension is 15 mm. And sorry, minus 15 mm. Have to enter weight. So spectacle blind, go to the here 5.39. Just enter 54 kg, 54 Newton. Sorry. And then 270, minus 270. So one valve is the gate valve. This gate valve. Six inch. Flange gate valve. 6 inch 150 rating, 88 kg. So 88 into 10, 880. 880 Newton. Again on flange is the minus 89. On 38. Okay, so then if you go here, you will have 270, 324 on support is there. 324 minus 89 flange length. So minus 324 plus 89. Just I am giving one support, adding one support. Then 542. So So 542 minus 324. 542 minus 324. 218. 218 mm, sir. So minus 218. So it is continuing in the another sheet. So what we'll do, we'll go to the next sheet. This is other set of discharge line. So we have model like this, okay. So we'll go to the next sheet, we'll see. And this is going. So we'll see the model first. Which one is 47? This is 47. So this line is going and it is connecting to this discharge line. Okay. So we will model here. We model up to here only. So again we need to continue with the model from here to here. From here to here. Okay. Then we'll copy this entire portion and then we'll do this one. This discharge line. Okay. So go to the next sheet. So we have model up to here. We have model up to here. So go to the next sheet. So from here, after this one elbow is there, so this isometric is not available. See here it is coming, so this isometric is not available from here to here. So from here to here it is going like this. From the model we'll measure and we'll complete this one. So from here to here, just measure. So overall dimension is in the x direction, it is 1740. Okay. So after this, go to the next node. In the same direction, minus x. This is elbow length. Then go to the next node. So it is going in my plus z direction. So plus z is 1740 as per the 3D model. Since the dimension is not available, the isometric is not available, so we have measured from the 3D model. It is 1740. Okay. So at 1740 T, so enter 670 welding T, since it is a equal T. Okay, so go to the next node. Sorry, next sheet you will see. Okay, so here up to here we have modeled. Okay, so this is the second discharge line. This is for pump B. Okay, so it is like this, and it is getting continued here, and it is again traveling here from here to here. After that, this branch connection, and so here they are not continuing till the equipment, because from here to after this FRP line is getting connected. So what we need to do, we in order to segregate the system or divide the system, so we have anchored here. Okay, so we need to provide limits of rest plus guide plus limits of plus hold down support to be provided at this location. And here also it is not getting continued, because that is coming in different system, so that we have not considered. So what we will do, we will stop here. We'll do the discharge line. The other discharge will copy from here, and we'll do the modeling. 1 minute. We'll copy this one. So what is the node number? 10 to 450. Okay. So you have to remember 10 to 450, but you need to connect the line at 470. The end node number it should know. Okay, so your line will be coming like this and it should be connected like this. Okay, and it will be traveling. After that, vertical rise, and here your anchor point is there. Okay, so now I am going to copy this line up to this portion. Okay, so 10 to 370, this element, sorry, 470, 10 to 4, so 470 is that one, and up to 410, 450, yeah. So up to 450 we need to select, say we have selected there, and that one node number 450 to 470 we have not selected because that is going in horizontal direction. So right click this, block operation, duplicate, and you provide some other node number at the, not at the end of the, yeah, at the end of the input. At the end of the current block means it will be inserted after node number 450. Okay, so at the end of the input you give node increment. Since this is a different line, I am going to use 1000. 1000 means 1000 plus 10. It will be continued from 1010. Okay, and the last node number only you need to change it to 470. Okay, so you see it is getting pasted here, and this last node number you need to change to 470. Okay, if you change that one, you see automatically it got connected here. Okay, so here you need to remove the bend. Okay, that I will show. If you are not removing bend, what will happen? It will show some error. After that you need to remove. Okay, so next node, go to next node. So it is getting continued. Okay, so from here up to here we have model. So from here it is getting continued. So here this is the another pump. That one line is missing, no? So that line is like this. So this discharge is going like this. So this discharge is like this. Okay. So what we are going to do, up to here we have model. Then we, after this 936 mm till this T, 936 mm is there. Okay. So in the minus X direction, 936 mm is there. Okay. On support is there, we will see I have not provided support. So in that direction, sorry, in that location on T is there. So we need to apply T here. And after that it is getting continued to 142. Just I am modeling there, minus 142, and also the elbow length, just I am modeling here. Okay, so this is a T. From here only it is going upwards. Okay, so what is the node number? That is 490. Go to the next node. You change this from node to 490, then only it will be continuing from 490. Okay, and so it is 1907 plus 143. It is going upwards. 1907 plus 143. 2047. So the vertical 2047. And one bend is there. Select bend. Then again it is going in which direction? So it is going in Z direction. Correct, huh? So it is going in Z direction. Plus Z. That is 1059. Go to the next node. Z direction 1059. 659, sorry. Again it is going up. It is in, what is the dimension? 228 plus 717. 228 plus 717. So here I need to define the bend elbow. And then it is going in plus x direction. Correct? No? This is. So it is going in plus that direction and dimension is 687. I have to subtract the flange length. Here bend I have to provide 687. What is it? Minus 89 plus 687. Okay. So you see in the model, if you check the model, so it is going in different direction, but this ISO is having different, so there is a difference in the model and isometric drawing. So don't get confused because that is for other isometric only, train 2 only. So after this one flange is there, that is 89. Add weight here 138. So here one support is there, so you break this one and provide a support at maybe node number 300 or 350. So you need to check, and I will tell you how to check this, how to provide weld gap, how much weld gap to be maintained, if any shoe is there. So like that I will explain you in the different class. So hold down support, this is hold down plus y and minus y, it's hold down, and guide and limit stop. Okay, so now need to provide a guide and limit stop, coefficient of friction, because some clients they used to ask you have to provide coefficient of friction for the guides and limits of also. So you need to study the stress design basis. Based on stress design basis, you need to provide the supports and coefficient of friction. So you see, I mean here one support is there. I have not added the support. Just will add a support here. What is the dimension? 936 minus 633. 936 minus 633, 303. So control B, 303. If you know any other support number, you can give. So if you don't know, just enter and plus y. Okay. So here we have provided the support. So once we complete the pipe modeling, so now we have completed the pipe modeling. Generally, if you if any tie-in point, this is a tie-in point location. This is a tie-in point location. Okay. So here we have made it as fixed. So this is the correct one. So here also fixed and here also fixed. This is pump. So it is connected to the equipment. But you see, this end is free. You should not leave like this. But in this project, they have done like that. So you should not leave the this point. You need to model the next line up to the next anchor support like this. You need to model somewhere here. I don't know where it is getting connected. So you should not leave like this. Okay. So please remember, don't don't consider the free end of the pipe. So all pipes should have, at the end it should be fixed somewhere like this. If it is going like this means, so you have to fix at some point, or you get the detail from the other vendor and include it in your analysis. Okay, so that is a best practice. Don't leave like this. So then we need to model the pump. So pump discharge line. So in the section we have seen And in the discharge, how we are going to model. So this is a discharge flange. Yesterday we have seen it is N2. It is your discharge flange. Okay, this is your discharge and this is your discharge. So up to center of the suction line, the dimension is 279. Okay. So what we will do, go to this node number, first node, and C node we have provided. Go to the lowest node and Alt C. So just give 11 here. So what we will do, already in the suction line we have considered 10,000. Okay, 10,000 and 10,100 for the pumps, and for the equipment maybe 10,500 or 11,000 we have provided, or we don't know. 1 minute, I will delete this and I will check the pump, sorry, suction line. Where else? Go to the suction. Okay, this is the suction line. So here, so this is 10,100. From 10,100 we have started. Okay. So I have model like this. That is not correct. You see, here we are given 10,000 from 100 we have started. So at least you should have started in a different node number here. I am going to renumber this one. That is not correct practice. So what I will do, I am going to select like this. Okay, control, press control, right click, renumber, and start node is I am going to give 11,010 and node decrement as 20. Just okay. So now you see it started from 11,010 here. Here I didn't change, but automatically it got changed. Okay, because it is already connected with C node. So if it is connected with C node, no need to change this node number. If you change from here to here, it will automatically change. Okay. So here we are 11,000. So we have used 11,000. I'm going to the discharge line. And this is 11. So, and go to the last element, 11. So now I'm going to start from 12,010. I'm going to model the pump. So one flange is there. That flange, what is the size here? 3 inch. 3 inch 40 years. Okay. So already we have seen flange 16.5. Already we have seen that is slip-on flange. 3 inch slip-on flange, 300 rating. Dimension is 41. So minus 41. Weight is 5.9 plus 3.08 kg. Sorry, 6 plus 3, 9 kg. Around 9 kg. So I'm going to enter 90 Newton here. Go to the next node. So now how we are going to model is from here to here, and then after that from here to here we are going to model. So generally if you have different system means, so you need to model up to the anchor. Okay. So 279 minus up to the center minus 279 plus 41. Correct, huh? So make it as rigid without weight. So this is up to the center of the suction line. Okay. The suction line is like this. Maybe your suction line is connected like this. Sorry. Like this. Okay. So go to the next node. Up to center we have modeled. And this dimension, so yesterday we have seen, no, this is 221, I think. So minus 221. Double click this, anchor. So this is a discharge line, pump modeling. And here you can copy this one also. This three. You should know this. What is the C node of this one? 1011. Okay, so here element. Here you copy this. Block operation, duplicate. End of the input. Just give 100, 1000, because 1000 means. Why I am giving 1000 means that C node what we have considered for the other pump is 1011. So if you add this one, it will become 1011. So automatically it got placed in, it will be connected to that particular pump, you see. Oh sorry, 1000 I have given, sorry. I take you 1000 only, no? So I given 1011. Here you have to give 1000. Then only 1000 plus 11 it will give 1011. Okay. You see here it come. So automatically it got placed there. Okay. So now we have completed the modeling for pump discharge line, and pump also we have modeled. So maybe if it is connected to any equipment, this line is getting continued here, you see. So it is going somewhere, sorry, this line, and it is connected to this blue color line. So it is connected to some other filter. Okay, this here only it is getting connected. So this blue color line is FRP or GRE line. See, the modeling itself it will be different. So that's why they splitted that one. Okay, so we have our scope is ended here. Our scope is ended here. After that it is getting continued. Okay. So now what we need to do, we need to assign T4 and T5. So since we have copied this file from suction line, so we have assigned the temperature for T4 and T5, but we need to change accordingly. Okay, here if you check T4, all over 40 degree only. Okay, and T5 all over 40 degree. So now we need to see from where you need to, which for suction, which line we have considered T4 A as standby, correct, no? A pump as standby, T4, and this is working. But T5, A pump A is working and pump B is standby. So like this we need to consider here also, because we are going to connect the pumps, pump suction and discharge line. Okay. So if you are giving other way, then it will not match. So once we get connected, again we need to change. So before that, you have to ensure the same temperature distribution has to be followed for the discharge line also. Okay. So now you see. So but now the flow will be in this direction now. Correct, now. So what we have modeled is from here it is going like this, and here and it is going like this. Okay. So what we will do from start onwards, if T4 is operating, you need to standby, you need to make this one as 21 degree. Check T4. You see up to here 24. So this is valve, and this is NRV, and this is gate valve. So from this flange onwards, you have to change again to 40 degree. Okay. So after this, there will not be any fluid flow. I told you in the other video, no, for the stagnation condition, you can use the average temperature. For the suction also the same thing. Once you combine the file, I will tell you. Okay, means 40 plus 21 divided by 2. So 30.5 temperature has to be provided. We'll see. Okay. So this is for T4. For T4, this pump is standby. This pump is standby. But the pump, for the pump you have not defined the temperature. So what we have to do, go to the particular node and change that one to 21 degree. T4, in T4 only. Oh, sorry. So now this is correct. Okay, this pump is standby. But you see, this pump also, the temperature has been changed. So what we need to do, we need to change T4 as 40, because since the pump is working, you know, this pump only working in T4 condition, that is temperature 4 condition. Next, go to T5. So in T5, all over on operating condition, what we need to change? We need to change this one from here onwards, because we have started the model from discharge line. So make this one as 21. After this valve, after this flange, you make this one as 40. Okay, then only it will be correct. Otherwise, what will happen? The temperature is wrong. You see, your fluid will be flowing like this. Your fluid will be like this. It is going, it should go like that. But here it is 40, but here it is 21. So you have to change the temperature from this valve, because this valve only will be closed, will be in closed position. So enter 40 degree, and then, so this is correct, 40 degree this pump also, but this pump also it is changed to 40 degree. You need to change T5 as 21 degree here, then only this pump is standby. So now it is correct, you see. Okay, so you save this file. So once you completed this, what we need to do, we need to check the errors. First we will check the inputs. We need to, like this, insulation density, fluid density, pipe density, corrosion allowance, there is no corrosion allowance, pressure, hydrotest pressure, temperature 1, temperature 2, 3. Since all lines are having the same temperature, so there is no issue. If different lines will have different temperature, then you have to check properly. T5, okay, then uniform loads, mill tolerance, thickness. So thickness, it should be correct, okay, and OD, and then insulation thickness. There is no insulation here. Code, materials. So everything is correct only here. Okay, save. So once you complete this one, what we need to do? Start run. Okay, you see, error it is, if you run this one, you will find one error. What is the error? Error number 5A. Bend angle on element is 0 degree. It must be between 5 and 90 degree. So this is actually, this is not a bend. So you have to delete this bend, because it's a T only, no? You select here, you will get T. So this is T. So wrongly we have given, because we have copied this file, no? So here it is bend. That's why it got copied, and this bend also repeated. So I need to delete this bend. If you delete that bend, your error also will be removed, you see. So there is no error. And you have to build the load cases. So already we have seen the load cases. So what we'll do, we'll keep like this, and we'll combine the file, then we'll build the load cases on the combined file. Okay. So this is a suction line. What we'll do, 1 minute. Just save this file and rename as pump suction discharge. This combined file. CAESAR-2. Okay, so now I'm going to open this file. So I told you already how to combine how to import the files. Okay, so for this, so first you need to check what are all the node numbers we have used here. So this is up to 11,000 we have used, and for the piping we have used up to 2,800, that is 3,000 something. So what we will do, and for the pumps we have modeled up to the anchor here. So for the discharge line, what we'll do, we'll remove this portion. We'll remove this portion. Okay. For this, 1 minute, I will discharge. Just one more file I'm getting. Original file I'm keeping the import. Okay. So I'm going to open this. We need to remove that pump, this one, because it will get connected here. Okay. So we'll remove this one. Control D, delete, select and delete. Control D for delete. Okay. And you need to renumber the nodes, because 10 already it is there in suction line also. Node number 10. So up to 2,850, that is 3,000 we cannot use. Up to 2,850 you should not use. So what we'll do, we'll select all the pipes. Don't select the pumps. Okay, up to here for the pipes. Block operation, renumber. I'm going to renumber from 3,000. Okay. Or 5,000 if you want to change this, 5,000. Anything you can give. 20. Okay, see. 5,000 only. See, the node number has been changed to 5,000. Right now? Yeah. And no need to change this one, pumps, because already we have considered the different node numbers. Okay. So what you save this one, go to pumps, that, where is it? Pump suction discharge, this file, and so where it is going to connect, discharge line, where it is going to connect, from this node only. Now I will show, if you are not given the proper node number, proper connecting node number, what will happen. Environment, environment, pipe, include piping input file, browse, pump discharge to import. Here you have to select that read now, select N, So if you select N means automatically at the top you will find the same thing. So in that N, the top one, you have to change it as Y, that is S. You see the file, I mean we have imported the file. Okay, but it is connected in the some other location. At the first node it got connected. See, at node number 10 just it has appeared. Now you can change like this also. So what is that 12010? So it should be connected here. What is that node number? 10,010. So here instead of 12,010 and it is 10,010, sorry. And here, what is the node number? 13,010 to 13,030. Okay. So it is in downward direction. And 10,110, we'll see. So in the downward direction, 10,110. So you see these node numbers only it is going there, and you need to see 5010 if you have any connection. What is it? 5000. So at 5000, yeah. See what is the issue means here. In this file also you have 10 node number. I mean C node has 10. 11, sorry. Node number is 10 and C node is 11. So whatever file we have imported, in that also the same node number it is there. That is the issue. That's why it is not getting connected properly. So for that, what we need to do, we need to change the node number in the other file. So Control Z I am giving. Okay, now it is not imported. What we will do, we'll go to that file and we'll change node number. You see, pump discharge. 1 minute. This is different. So if you find that .a, so there will be some issue in that. Okay, now it is okay. So here, what we need to do, that's what I told you clearly. The node number, whatever you use for the other file, should not get repeated. Any node number, one node number also, if you have, then it will be an issue. It will not get combined properly. So now you see what I am going to do. Here I am going to change 5001, and for the pumps I need to change 5001 means 11. Where is that? That 11 is there. No, here you have to change it as 5001. Now you see it is got connected. Now here also you need to change, because 1011 also it will be there. So I am going to change as 5481. Then go to the 1011 node number, find Control F, find 1011. So here 5481. You give 5481, it will get automatically connected here. Now you have to check thoroughly if any other node number is getting repeated or not. Okay, so it is not getting repeated, all are in different tone only. So go to that pump suction discharge line, environment, input file, browse, import, and OI. Okay. So you see, you could not find the model because it may be somewhere. So 5000 I'm entering, so it will go to that 5000 because we have not given proper node number at this. But understood? No, because your suction line is like this. Here they are anchored, and your suction line is modeled like this. So this node number of the suction should be changed, or you have to change this discharge node number at this location as a suction node number. Okay, so we will go now to the suction node number at 10. The model will be here only, you see, somewhere here, because the coordinates will be different and everything is different. So we didn't check the coordinates for the discharge line. Now we'll see. So now we have to connect. We have to renumber this one. This 10010 because our discharge line is like this. Okay, so here our nozzle is there. So here this node number 10,010 has to be changed at your discharge node number. That is at 5000, 10,010 here. Here you have to change it to 10,010. If you change, you will see automatically it will get, sorry, not here, sorry. At the bottom only, yes. Two node number only you have to change because you are going to connect here, no? 10,010. So now if you double click this one, automatically got connected. Okay, and so there is a difference because this is from different model. This discharge line is from different model, and this suction is from a different model. So you need to change, and this node number has to be changed. What is this node number? 10,110. So you have to change this one, 10,110. Okay, so you see automatically it will be connected here. You need to change the difference. You need to change the dimension in Z direction. Because you see this pump it got connected, but this pump we have some gap here in the Z direction. So 54812, 54802, 10,110. The Z direction you need to see the dimension. So 291 mm difference is there. So what we'll do, we'll reduce this 291 at this node number, minus 291. Now you see it is getting connected here. Okay. So suction line is this one, discharge is this one. Okay, now what we'll do, we'll check the temperatures. (82). Is 40. 21 is here only. 4 degree. And T4, this is working standby, you see. So this entire pump, it's standby. both suction and discharge. It is in standby condition. So only this portion, I mean, the fluid will be coming here and it is flowing like this, okay, and it is going like this, and it is traveling somewhere, okay. So this, since we have closed this valve, there will not be any fluid flow after this. That's why we have considered 21 degree, okay. So in some cases, some clients, they ask us to consider the stagnation portion, because fluid will be coming here, so some fluid will be flowing up to this flange, okay. The stagnation temperature, you can change the temperature as average temperature, mean temperature, they will call it as mean, 40 plus operating temperature plus ambient temperature divided by 2. So what we got is 30 degree something, no, 30.5. So you can give that temperature also here, or you can leave like this, 40 degree also, not an issue, okay. And for T5, yeah, you see, so this pump is not working, so that's why temperature also we are given 21 degree. Okay, so now we have defined the temperature, everything is correct, and then check start run. You need to see any error is there, so there is no error. So what we will do, we will import the load case from other file. So we will define wind also, just because for other file we have wind, okay, wind shape factor. And what we will do for the uniform loads, we will define in Y and Z direction also, 0.141, okay, the Z 0.141, always you have to define diagonally, okay. So if only if you are using two directions, I mean if you are using the uniform loads or earthquake in two directions, so you can use U2 as UZ, okay. Now U1 is X direction, U2 is Y direction, and U3 is Z direction. So if you are not using UI, I mean plus, I mean vertical direction, then in the horizontal direction, you can consider it vector 2 also, okay. So now if we see, because already uniform load we are given for discharge line also, here you see on the list you can go to uniform load, so you can find the difference. At node number 1 we have changed, X is correct, and Y we have defined, Z also we have defined. So what we will do, you will remove this, because vertical we have considered as 2, second vector, so I have removed the second vector. And if you check the uniform loads here, so in X, one is X 0.141 and 2 is Y, 3 is Z, okay. And for the wind also you have to check. Wind, it is 0.7 everywhere, so it is okay. What we will do, we will import the load case from other file. So this is a load case editor. Then on the top you see, if you want to save means save load case, add a load case means add, you have to add, and delete a load case means you can delete the load case, okay. And recommended load case means CAESAR will recommend some load cases based on your inputs. So this, if you want to use, just accept, so it will be changed. You see, this is a recommended load case from CAESAR. And then import load case. So import means you can import from any other file, or you can import from CAESAR file. What I will do, I am going to use from some other projects. For example, some other projects, expansion joint, 1 minute. So we can see if you are going to use okay, so I am going to use this file. You see, in this file you have everything. T1, T2, T3, T4, T5, and Win1, Win2, Win3, Win4, plus U1, minus U1, plus U2, minus U2, and plus U3, minus U3. That is for seismic loads. And then WNC case. This WNC case is important for the pump lines, because what we will do, we will check the. I will tell you in the later while checking the results. Okay, so what is the use of this case? So WNC means it is a weight, no contents, only pipe. Just consider the pipe without fluid, anything. Okay, just pipe weight only we are going to consider. And wind loads, it is already defined, so we are considering from there. After this, you save this file and analyze load case. This is there, no? So now we are going to see the result. And I have not defined any flange leakage and all here. So we'll define a flange leakage and see the result. First we'll check the results. So okay. So these many load cases will be there. Generally, what is how to check the results? Okay. So first, what is the purpose of stress analysis? You should understand. So in CAESAR-2 we are doing pipe stress analysis. First, you should understand the pipe stress analysis purpose in order to get the flexibility of the piping. Okay, I will show you some slides regarding this.